All right, so today we are going to talk about using how to use the area diffraction machine to integrate area X-ray diffraction patterns like the one that you see here into a more common form like, let's see, an integration pattern like this where you have intensity versus degrees 2 theta or Q. So the first thing you have to do is to install the program, and so here if you go to the Downloads tab, if you go to this area diffraction website, you can go to Downloads, and you can download both the Windows format or the Mac format of the program, and you can also download the PDF of the owner's or of the operator manual, which has a lot of really pertinent information. So if you have trouble, you can always go there. The first thing that you're going to do is to do a calibration. So you want to open your data by clicking on the little folder icon, and then you will want to open Lab 6 or Quartz or whatever it is that you are going to use to calibrate your data. So open the pattern, and you can see here it shows what the program is doing, because some of these files are very large and sometimes it takes a couple seconds for it to open. All right, so once your data is open, once you've opened your standard diffraction pattern, you're going to want to choose, you want to go to the calibration tab up at the top and say get the parameters from the header. And you're also going to want to say, when you're calibrating, you want to say that you want to go up here and say standard Q, and then select lanthanum hexaborate. So then that's loaded. You get the file from the header, and then you go ahead and say do fit. And so it fits the parameters that it got from the file, so that it does a good job of fitting the peaks that it observes in your data. And you can see that this actually fits quite well. The peaks are definitely well represented here. What it thinks are the peaks are drawn in red, and what you know to be the peaks are what's in black in the pattern. So after you've calibrated, you have these parameters you have these calibration parameters, and so those parameters are going to be valid for all of the data that you collect without changing the detector distance or anything else for your whole run. So you're going to want to save those to file so that you can use them again when you're integrating your data. So you want to save to file and then just save it wherever it needs to go. I'm not going to do that right now. Open a data file. So we'll open a data file and wait for it to load. So here it is. This stuff isn't very beautiful. It's not very crystalline. It's very hydrite. So you can see you don't see the nice peaks like you did for the Lab 6 standard. So you're still using these same calibration parameters, and those will stay there until you either change them or until you close the program. So now let's go to masking and say I want to do a greater than mask, so you can mask off pixels that are greater than 50,000. And let's pick a color for that, and we'll make it green. Okay. That doesn't seem to have done anything. Oh, it's still drawing. So you can see down here it's still drawing. So it's still thinking about which pixels that might be. I don't see any of those, so maybe we'll come down to 10,000. No, none of them are out. You can also do a less than mask, like less than 0, and we'll make those blue. We'll say OK. Maybe we'll do less than 30. And so it's drawing that. Obviously, the areas outside of where they're not collecting any data are less than 30. Some of these guys in the beam stop, so you can see the beam stop here. You can also do a polygon mask to cover the beam stop. So I'm going to save this mask. I think I'll actually just save it on the desktop for the moment. So we'll just save it on the desktop. So let's remove the polygon. So we're removing the polygon in red. And then, well, let's see. It's clear mask. So we'll take that away. And in order to add a polygon, you're going to need a 2-click mouse. So you just click once with it's left click once, left click once, left click once to draw whatever shape you want. So every time I click, it makes another point. And then when I finally want to end, I right click and it goes away for a second, but then it draws in the polygon. So however you want to do it, you want to mask off the beam stop. If you want to mask off, you can mask off whatever you want. All right, so now let's go on to the cake tab. So I like to do an auto cake. It's not going to be very exciting for this particular sample, but you want to make sure that all of your lines are, if you have a crystalline phase that's not under stress or strain, you should have straight lines up and down across the page. And you can see how the mask is translated onto, or is superimposed onto the data. This is basically just cutting the pie open and laying it all out. So it's basically a square or a rectangular representation of this image. And you may want to save that data so that you can go back quickly and make sure that everything was, that you seem to have the appropriate calibration parameters, and that these lines are all straight up and down. But we don't really need to do that. And in order to do that, you can either save the image or you can save the data. And you might save the data if you were looking at stress or strain and you were interested in anything that wasn't perfectly straight up and down. If you want to save the image, that way you can go back. Let's see. So now you can integrate, which is where you get to the, which is what you're going to generate. Here, let's just do an auto integrate. So I like to do the 2 theta I integration, and you can either integrate work in Q or you can work in 2 theta. I'm an environmental scientist. We don't work in Q, much to the chagrin of every scattering person I know. So go ahead and I just click auto integrate right at first. So the lower limit's 0, the upper limit's 58. So here's the data that I come up with. I actually don't really like having too much going on here. I'm not likely to trust anything at super low degrees 2 theta, and this up here actually makes it difficult to integrate as well. So I think I'll chop this down and maybe integrate from 2 to say 47.5. And we'll say that we want to increase the number of points the number of points it's going to choose from the center of the circle to the edge of the circle when it's integrating. And I'll just ask it to integrate. It takes a second, but here you can see that actually I do have some peaks, even though this is a relatively amorphous phase. But you can see the integration. It looks much better when you don't have the weirdness going on at high and low 2 theta. And then you can just go ahead and save your data. So we'll save it here on the desktop as fairy test. So we'll go ahead and save it there. And that's how you use, and now the next step is to go on, this is how you use area diffraction machine, and so the next step is to go on and use, is to translate this data using Excel into something that you can import into either JADE or Expert Plus or whatever your data analysis program is going to be for this X-ray diffraction data. All right, so in order to do this next step, what you're going to have to do is make a copy of the data file that you saved from ADM you want to make a copy of it, and then you want to change the file extension to .txt. So Excel doesn't seem to want to import the .dat file, but it will do just fine importing a .txt file. But you don't have to do any additional changes to the file itself. So you can also open this file. This is why you want to make a copy, because you're going to open it and then you're going to delete everything that's not actually data. Has a lot of information in there. And you want to take out everything that's not data. You could also crop this. If you didn't crop when you were integrating, you could crop it that way. All right, so now let's go to Excel and just File, Open, grab that, and just say Open. And now you're going to say that it's delimited, tab delimited, next, finish. So here we go. We have the data open. You could plot it from here directly if that's what you want to do. But you can also, what you're going to have to do is save it as ASCII file, so that Jade actually can import just a 2-column text file like what we have right here. But if you're going to go into Expert, it can only import ASCII.asc files. So we need to save this as an ASCII file. So file save as. Let's save it as an ASCII file. So now you're just going to save it as a text file. So you save it, and do you want to replace it? No, I don't want to replace it, so I'll make it 3. So save that, and we'll just continue. And then now you have something that you can import into Expert Pro.